Okay, my testing 1, 2, 3. Okay, let's continue our lecture. So just now, before the break, we go through three equation to calculate the number of subcell 2L plus 1, total orbit n square, and maximum number of electron that can fit into that principal quantum number is n power 2. Right? So this second half session, we'll look into electron configuration and orbital box diagram. Okay. Meaning, how do we draw this electron, position of electron? So these are the key things. So electron configuration notation consists of N, principal cell, subcell L, and ML or MS. Okay, so still you need the four numbers, the four numbers. So let's look at how electron configuration for oxygen. Oh, right. So you're at you're in your tutorial question 51. So if you open your periodic table, oxygen is over here, right? So by looking at the periodic table, you have two numbers. On the top is photon number, right? Proton number, which is the electron number of electron. This one 16 is the AMU number, or is molecular number. Okay, so you know that from periodic table, oxygen have 8 electrons. So now we want to write the configuration electron for the oxygen, right? But very easy, It looks complex, but very easy. Once you have periodic table, you're able to write the configuration. Okay, I copy the image there. So first you use the first equation, 2n power 2. You calculate the maximum electron that can fit in. All right. So, and the table that we've seen just now, each one have their maximum number of electron. So for oxygen, you can write like this. How do you write like this? Okay, I give you a shortcut. This one might not be in my slides, but this one is in my lecture. So how do you know it is orbit number 1 or orbit number 2? You count the column. You count the vertical column. This is number 1, right? You see the number on the periodic table. So if you have 1, means the n have 1. We have n2 means is 2. We have 3 means 3. Okay. So for oxygen, it fall under column 2. Oh, sorry, not column. Row number 2. So n2. You calculate maximum number of electron. 2 square is 4. 4 multiplied by 2 is 8. Right? Or you can look at the number 8 here. But this number 8 sometimes very confusing. Better use this electron because sometimes there's a sharing of electron and so on. Okay. So once you know that electron is 8, right? Oxygen is, you have two, we call two principal orbit. So you have 8. So how do you know total orbit again? Total orbit is number 2, right? So 2 is 4. All right, number of it, you have 4 orbit there. All right, then number of subcell. Number of subcell is the L number. So L number, you want to guess lah, right? So you have N. So you can draw diagram, either you draw vertical or horizontal, never mind. So for oxygen, you know that is from the periodic table, you know that is N2. So number of electron is 8. So number orbit N2, you have 4. So you know that this is N1. N1, inside N1, you only have S, because number of orbit for 1 is 1. Because you use this equation. Number of orbit for N equal 1 is 1. So when you come to 2, you will have 4, right? You have 4 orbit here. So you have 4 orbit, but number of subcell, you need to calculate. So 4, you have S. You start with S and then P. So S is 0, P is 1. So this is, you don't have any subcell for 1. But when it become P, you have 3 subcell here. This is, you have one subcell. So when it come to 2, you have 4 line there. 1 is S, 3, 1 is P. Then you start to write the electron. So this is graphical. This is graphical. So you know that each lane or each line will present 2 electron. You just put in the electron and then transform it into the configuration number. So 1s means orbital number 1, and so on. So through this graphical diagram, for oxygen, 1s2 means 2 electron inside. So you have 8 electron. You have 2 already, means you have 6 more. So you continue with the second one, S. S, you have 2. And you have another 4, right? So 2p4. How many electron can fall into P? 6. But you only fill up to 4. You have 2 more empty space here. So this is the configuration to write in orbital form, orbital bomb. So this is the first skill that you need to learn for second half. You need to know how to write in the orbital configuration in this number form. Okay, first you start with the graphical things and these 3 formula, and then you fit in based on the total number that you have, not total number of electron you have. You fit into orbital. Okay, so at this moment you only need to learn about this number. In later chapter, when you have chemical composition or chemical reaction, then you need to guess whether the electron is fit in or released. This is the orbital box diagram. Based on this number, you draw into box diagram. So means each line, each red line on the whiteboard here, you change into box. So this is first line. So it become two box, means 2 lane. And then you fill in the arrow, go up and go down. Mean it spin this way and another way. Okay, so this 1s2 means 2 electron, 1 go up, 1 go down, so that it balance the force inside the orbit. Then you go to 2s, 2s also 2. So 2s, so you do 2s. 2s is this one. However, when it comes to P, P or P, you know that you have 3 subcell. How you know have 3 subcell? This one, by using 2L plus 1 equation. Okay. Because P is what? P is 1. So here you get 3. 3 subcell means you draw 6 box. You draw 6 box. You fill in, you know that you have 4 electrons. You fill in positive, negative, means go up, go down. The remaining 2, you need to fit into the lane. You need to park the car first, you will not always, don't leave this one blank. You will fill in the blank first. Okay? So this is how you draw a box diagram. So this is normally in, when it comes to question, this one normally in section A, draw diagram or the orbital configuration formula. Either these two, either electron configuration. If you see the question asks you to write electron configuration, meaning we're expecting you to write this one as P power something, then convert your electron configuration into orbital box diagram is this one. This one normally fall into question section A. Okay, any question on the box diagram? Easy, right? Okay. So let's try another one. Let's see if you're able to do. So next one, we look at nitrogen. So we look at nitrogen. Where's nitrogen? Here. It's just beside the oxygen. Also 2. But you look at the number here is 7. You know that it has 7 electrons. But you can still count if you want. Okay. So nitrogen, you have 7. This one we look at one element, because stable one is N2 but we look at one element nitrogen, N. Okay, N7. So you know that you have 7 electron, but they fall into N2 in there. So still find maximum electron first. Maximum electron that can fit into this N2. Maximum electron 2n squared. So you have 8. Right? So maximum you have 8. So if you know that n equal 2, you draw the diagram, and 1 and 2. So N1, you have how many orbit first? So this one, N2, you have 1 orbit. This one, you have 4 orbit. Then how many subcell you have? So this one, 1 orbit, 2L plus 1. N equal 1 is 0. So here you have 1 suborbit. So you have S. Then you go to N2. N2, you calculate. Number of orbit, N2 is 4. How many subcell? So you start with S. P. S is 0. P is 1. So here, subcell 2L plus 1, you have 1. 2L plus 1, you have 3. How many electron you have for orbit? This one is 2 electron. We're calculating 2n squared. This one is 8. Maximum electron. So you have 8. So this is 7. You have 8 parking slot. Not 8 parking slot. You have actually you have 10 parking slot. 2 plus 8. Okay, So you draw into normally. So you write lah. So you have this one, 1s square. You know that you have 7 electrons. So you fit in 2 already. So 2s square, 2p, how many? 3, yeah. Then you convert this electron configuration into box. Go up, go down. So don't make mistake here. Sometime when it come to final exam, I don't know, somehow your brain jam, you draw 2 arrows together, then wrong answer. This is wrong. You must have contradict. So 2s also same. Go up, go down. But 3p you have 6 lane. 3p you have 6 sorry, 3p you have 6 lane. So draw 6 box. Okay. And then you fill in 3. 1, 2, 3. Okay. So everything I explained to you is on the screen and also on the whiteboard also. So electron configuration, this form, orbital box, you draw the S first. S normally you'll fill up first. The parking lot will fill in first. But when it comes to suborbital, you fill in the empty parking lot first. So 1, 1, 1 like that. Okay. Make sense? Yeah. Okay. And also this arrow is important. Always on the left side of the box is always pointing up. Right hand side is always pointing down, just to illustrate the movement of the electron. Okay, we have clear oxygen, nitrogen, so you should able to do when it comes to your test. 1, maybe in your final exam. Test 1 sure come out 1. So you should able to draw, give electron configuration and also orbital box diagram. Remember to label your box diagram, 1s, 2s, and 2p. Remember to label. Don't just draw box and then assume I know what you're doing. Okay? And also use the notation that we learned in class. Don't change S into something that you think of yourself. Don't write this one 1s, then become KLM or so on. Use the one that you learned in class. Okay? If you want to use your own symbol, explain in your answer. S is a first subcell, and so on. If you want to use other notation other than the lecture symbols, you need to explain in your notes. If not, I would put a question mark. What is this? Okay. All right. So these are the example for hydrogen, helium, lithium, and so on. These are the example. Okay. So you can test yourself and you compare to the answer on the screen. Let's do one example. Show the electric structure of titanium using orbital box diagram. So I give you maybe 3 minutes or maybe 2 minutes. I give you this periodic table first. Okay, by looking at this periodic table, are you able to give the electron configuration and box diagram? Titanium, where is titanium? Titanium, huh? Oh, you see wrong, okay. 81, oh, this one. This one is TI, T something, TL or something. Okay, titanium is TI. Of course, in the question, it will still bracket for you. What is that? Okay, so TI have a 22 electron, as you can see on the periodic table. Then use these 3 equation. Number of electron maximum that you can fit into that orbit. Then calculate number of orbit for that. Then calculate subcell. So draw the sketching first. Draw the line, sketching, and then convert into box diagram. You should be able to score if this kind of question come up. Okay. I'll show you the answer. So again, check the periodic table, titanium 22 electron. Then you check with the principal cell number. The maximum electron, you should get 32 because n equal to 4. Based on the periodic table, n equal to 4. Who don't understand why n is equal to 4? Who don't understand why the n is 4? Can? Can I? N 4, Okay, based on, okay, is it 4? 3, sorry, 4 or 3? 4, 4, okay. N is 4. I think some answer is wrong. Okay, ours should be 4, 32. Agree? 4 should be 4, N should be 4. Because periodic table show you is number 4 here. That is the cheat way cheat way by looking at the periodic. Of course, you can go through by diagram, but you can speed up by looking at the periodic table. So since you have 32, SPDF. Okay, so in this form, so you can calculate can calculate. So this one is what I explained just now So this is also another cheat way using periodic table. So what mean by column N1 means 1s. You can make in your own notes when you do your revision. If 2, you have 2s 2p6. So this one you can make some notes there. Then this is by calculating the n. So then the third one is n equal 3. N equal 3 is that okay. How do you know? Okay, how there's a cheat way, a cheat code. You watch on the screen. How do I know 1s2? I count the box on the periodic table. For example, the first row, I have 1 box, 2 box. So I write 1 as 2. Then the second row, I have N2. So I have, of course, I start with the 2s, 2s squared. So I have 2 here, 1, 2, I fit into s. How do I know 6? How? 1, 2, 3, 4, 5, 6. Meaning in row number 2, N2, you have 8 electrons. Correct? So you count using periodic table will arrange in such a way so that it's easy to refer to. And you will use this periodic table throughout this module. Then you reach titanium, right? So you have 1, 2, 3, 4. You have 4 electrons. But you know that this is, you sure will go to S1. This S, subcell S. So 2 already, balance is another 2. So you'll get, sorry, the third one. So you're in 4, sorry. So 3, 1, you also count 2s, and then 1, 2, 3, 4, 5, 6. So 3p6. Okay. So this do the calculation for you over there. Then you continue to count number 4. 1, 2, 3, 4. So this is S orbit. This is P orbit. Very easy to see, right? So those don't come to class 1, maybe they confuse. Okay, so if you come to class, you know already. Based on the periodic table, you can straight away write electronic configuration by looking at the left-hand side or right-hand side. Left-hand side, these 2 columns is represent S. The 6th column here represent P. So you count, like for example, titanium, 1, 2, 3, 4. 1, 2 is S. Another one will fall into P section, right? Oh, sorry, another one, D. I forget now. The middle one is D. Is a just now in our slide, D is a transition metals. So our titanium into a transition element. So we need to take care of the D segment. So in your periodic table, you have S, P, and D. Then just now we know that there's an overlapping of the orbit, right? So but don't worry, you just look at the periodic table, keep on counting only. Now, for example, this case. For example, this case, you have 4s, 4d squared, and you have no P. Because the energy level is not yet reached P. And periodic table, it tells you this region is D. So you write 4s squared, 4d squared. And actually, you can sum all this together in one term. It's a long answer. So this is a long answer. Meaning you can write 1s2, 2s2, 3p6, 3s2, 3p6, 4s2, 4d2. This answer also correct, but is a bit long. What happens if in the test I give you somewhere below here? Well, then very long. So is there any shortcut or short way when scientists write the element? Is there any shortcut? The answer yes. These 3 up to here, you see argon, right? You see argon element, right? So argon element represent from this term 1s squared until 3p6 electron configuration. So you can equivalent this 1s squared until 3p6 equal to argon molecule. So that you don't need to write so long this one. Unless the question asks you give in long answer. Give in long answer means full electron configuration. But normally when it comes to final, we will expect you to write shortcut answer. So what does it mean? Short answer, you only need to write bracket argon And the short answer, this one. This answer, short answer, is how you communicate with the chemist. Long answer, normally you communicate with the new learners, with the beginners. They want to digest how this number come from. Then you are at a higher level, then you straight away give this one equal to this one. Now, I'll give you an example. You already learned how to do this one, right? Okay, let's test whether you know how to give short answer. Let's say I give you the short answer. Give you can you write oxygen in a short answer? Oxygen. So what you do, you can write helium, or you can just count lah. You can write 1s square, and then you count this one, 2s, and then 1, 2, 3, 4, 2p4. This is long answer, but short answer you can write helium, then 2p square, 2p4. Sorry, this one is helium, He. Sorry? Sorry. Correct, 2s square. Yes. Means you understand. So in final, you can write short answer. Test one, normally I'll ask you to write long answer here. Huh? Because helium represent what? 1s square. It represent 1s square. Yeah, I understand. We just substitute lah, like you do linear equation, A equal to what? You just substitute A there. Like this one, like argon, like you don't need to write 1s until 3p6. You straight away use something to replace this. Understand? It is a this is a cheat sheet lah, actually. This is a cheat sheet. So once you understand how to use the periodic table to form the electron configuration, then you are okay already. Yes.
Your answer ignore the 3D. Yeah, 3D. You're supposed to use the 3D 2 plus 2, I think.
No, it's a 4. 3, sorry, 3, for these metals, it don't have 3. Or my periodic table is wrong. No, this one is 3, but for titanium, it don't have group number 3. You understand? Because the energy for the extra 4 electron, they rather stay in lane number 3, they jump to 4. Understand? Means here, the energy is higher than number 3 here. They jump to 4 already for titanium. Okay, so these are the answer for self-revision. So you can see titanium is here. The full answer is this one, but you can represent this one with argon. Sorry, 3d2. Yes. Okay, here is 3D. 2, correct. Titanium is 3d2. 3d2. This section here is D. Here to here is D. This hole is D, so it go into D. So my answer is, oh, it's 4 under 4, eh? Why is 3? Let me see. Titanium 3d2. Is it my periodic table wrong? Okay, based on the standard answer is 3d2, 4s squared. Check. It's because of the energy level. 3d2. Okay, so this is from first answer from the periodic table, but you can further check with the energy level, because if you go higher, actually it's more complex. So for titanium, the correct answer is argon and 3d2 4s squared. Why? Because I flip back to the energy level, diagram. Energy level diagram, this one. You see, it will jump to 3D first, then only P. You have 3D first, then only P, and so on. Okay, so you need to fill in the 3D. Let me check the cheat code on using the periodic table. Just need to be careful on the energy lah, especially come to transition things. Either my periodic table is incorrect. The step is what I show you in the class, right? Either the one that I copy from the textbook is wrong, or you need to be careful when you come to transition element, that you have element D there, energy D there. Okay. Okay. This one I double check lah, but the correct answer is like what we discussed. It should be 3D square, not 4. Okay. Yeah, so like this one, the 3D square is there. Okay. Okay. So just be careful on the D transition element. Okay. Transition element, especially just take note on that. Energy 3D is below the the 3. I think this one is more. This one. The 3D is below 4P. So you need to check lah. So, okay. But if in the test, if you're referring to the periodic table, and your answer you give this one, I also give you correct. Because this one is you based on periodic table. This if you give your answer in 4s squared, 4d squared, I'll still give you correct. Because this one you read from the periodic table. Okay.
Not such question like this, will the energy diagram be show up to them?
Yeah. Final you have tests. Maybe I should include that. Yeah. Okay. No need. Okay. Normally I won't test you up to below one. Only maybe this up to here only. Okay. So when you do revision, you test until here lah. You see until this, until krypton here. You test lah. You test all this answer. Normally I will not go until XE lah. Normally, yeah, maybe krypton is enough lah. Okay. The idea is to test whether you know how to use periodic table and do the box configuration. Okay, so this is another periodic table. So this one, yeah, okay. So this one with metals, non-metal, intermediate is a more simplified version compared to this one. This one have more colors. This one is more direct. If you see this one means it just tells you mixing between metal and non-metal question. Okay, next one you look at atomic size, ionization, and electron affinity. So what is a trend of atomic size? So this one, we use a definition of metallic in the periodic table. So the rest you read. So for metal, the distance between the atomic size is half distance between nucleus of two adjoint atoms of a simple element. What does it mean? If you draw two, let's say ferrum. So ferrum have electron on. So there's a center of that, then the distance is nucleus of two adjoint atoms. So this is the distance used as a metallic radius between the center. Okay, but anyway, this one I won't ask you. Only you need to know in a periodic table there's a metal, non-metal element. Okay, and another bonding is called covalent. Covalent is a non-metal. For example, chlorine, oxygen. The atomic size also half distance between the nucleus, but within the molecule. So the distance, the differences between metals and non-metal is that metal, we look at atomic dimension. Covalent or molecules, we look at molecules for covalent bonding and so on, right? So we look at molecule or covalent radius. Okay, the rest you read. So if the n increasing, so periodic table you have n, right? So n1 until 7 means if you go down means the size of the element is bigger and bigger. The size of the electron and the atom, right, is become bigger and bigger as you move down, right? So the biggest element that we know is this one. The smallest one is this one. Okay, so as it move down, then we become bigger and bigger lah. Okay. Charges of nucleus increase as you moving across this one. So you move down, become bigger and bigger the size. If you move across this one, it means the more charges it have. So this one positive, one electron, two electron, and so on. Okay, so if you move towards this one, you have more and more electron outside. It becomes smaller and smaller, the size. Okay, there are two directions. One is going down, n number, it becomes bigger and bigger. However, if you move from the left to right, because we have more and more electron, the electron will pack and squeeze. The electron, the size will shrink. Yeah. Because the more electron, the nucleus will pull the electron in. Yeah, there are two directions. So based on the electron, based on the periodic table, you should be able to predict the size, which one is bigger, which one is smaller. Which atom is bigger, which atom is smaller. If I give you two elements from a periodic table, let's say I give you carbon and maybe krypton. So which one is bigger? Okay. So of course krypton is bigger lah, because n is big lah. But I ask you to compare nitrogen and oxygen. Which one is bigger? Nitrogen bigger, because oxygen have more electron. It force the electron inside. It pull the electron inside. Can I? Okay. So the size of the atomic, it will influence the mechanical property. That's why that's why they put engineering material. You need to study periodic table for mechanical program. Okay, we're almost there. This is a note. If you see A1 means the statement that you see on the screen here, most of it is true. Means the A, the big group one. Transition one, because they are in transition element, because of the electron, they're able to jump into different lane. So sometimes they are quite confusing. We are not sure of their size. Like just now, the example of titanium just now, because of the D section, the D electron. Okay. This one, the bottom one, the inner, this one is less predictable. Means all these are non-predictable. Okay, so these are the qualitative diagram for element. So you can see from the periodic table also lah. So okay, what else? Ionization. Yesterday we learned ionization means to release energy, to release electron, right? To release electron. So ionization electron always positive when you release electron, right? So the first ionization energy, IE1, usually they use for chemical reaction. So for example, atom A, atom B, atom A before ionization, you have 2 electrons. You give energy, 1 electron will pull out from the orbit, and remaining 1 will become positive charge ion and negative ion. 1 element become ion, positive ion, negative ion. Okay. Positive charge, we call it cation. Negative charge, we call cation and anode. Anode can cathode. Yeah. Okay. Later we deal with this one. Okay. This is a quadratic table. Also can find in your tutorial question number 58. So what does it mean? If you look at periodic table, first one is the ionization energy increase. Atomic radius increase if you go down from top to bottom, the size become bigger. And atomic radius become, this one also same. Metallic characteristic drop if you go diagonal. Non-metallic become stronger if you go up diagonal. Electronegativity means tendency to become negative ion if you stay on top of the table. And the higher above the periodic table means it's very hard to pull the electron from it. Means you need more energy to pull electron from it because it's at the top. Okay. Okay. So this diagram that you can see from my slides. Atomic size. This one you read, huh? This one also another table that extract from the periodic table. So number of outer electron, it gives you a process called positive oxidation number. This one you learn when you learn about corrosion. I'm not sure whether we offer corrosion. Corrosion. All right. So oxidation. Okay. We look into this table when we come to that particular section. What else? This one you read, huh? This one you read. Okay, electron affinity is tendency to accept electron. Electron affinity is tendency to accept receive electron. Normally is at the right-hand side of the periodic table. Okay, because they have more electron, so they will try to pull electron in. This one you read lah. This is the electronegative value. So you can see number 4 here. It means it's very high tendency to become negative as you move towards right-hand side of the periodic table. This is just a relative number, no? Relative number. So where is 1? It compared to this element. Okay. Periodic table 1 and 2, they call it reactive metals. They are very low ionization energy, means they're very easy to mix with other elements. Okay. A few more slides, huh? To sum up the periodic table. Okay, so 1 and 2, they are electropositive, means that 1 and 2 on the left, they are more easier to let go electron. Means they're more easier to become positive. The term for that is called electropositive. However, when it comes to your test 1 or final exam, you forget electropositive, you can write like, okay, this element tends to release electron. Also, I give you correct. Okay, if you forget what is electropositive, the keyword there, but you can describe the behavior, right? Okay, so you form cation or cation, right? Then reactive non-metals, especially group 6 and group 7, they tend to pull electron from outside. So they call electronegative. They are electronegative metals. So they are formed anions. Anions, not anode. Anion. Okay, negative charge. Because they pull external negative charge. Okay, then there's one technical term. Sometimes we just give you a general metal plus something. What does it become? So metalloid, it means metals. Metalloids, group 3A in the periodic table. It can be metalloid, means it's either in metallic or non-metallic manner. Especially this one is a bit metal or non-metal. Sometimes it's a mixture. You can see this one is a metal, the rest is non. This one boron is metal, but in the transition metalloid, this is metalloid, this is metals. Right? The rest you read, 5A is a mixture, but based on color you can know what is it. You don't need to memorize. Okay, move down from here, it will become more metallic behavior. Move to the right is non-metallic behavior. So these are the two diagrams you read from the slides. Number 8, you know that is the stable noble gas. They are called noble gas. Sometimes the question will ask you to suggest what are the normal gas that can be used in the process. Okay, I think we stop here. Next lecture, we go into primary bond. We look at the bonding already. Okay, we stop here and see you guys after break.